Now we come towards transformer. Transformer is another device which is operating the principle of mutual induction. In the transformer, there will be two coils. One is primary, other will be secondary coil. The current passed in the primary and output is recovered from the secondary. The purpose of transformer is either to convert a low voltage into high voltage or high voltage into low voltage. That is, the voltage can be stepped up or voltage can be stepped down. So, we can find that it is an instrument which changes the magnitude of alternating voltage or current. The magnitude of DC voltage or current cannot be changed by it. It works with alternating current but not with direct current. It converts magnetic energy into electrical energy. It works on the principle of electromagnetic induction. As it is clear from the earlier definitions that electromagnetic induction is a phenomena in which, due to change in flux, there will be generation of induced EMF, and this induced EMF will give rise to induced current. Moreover, transformer is made up of two coils. It consists of two coils. The primary coil, in which input voltage is applied in the form of AC, sine graph or sine curve, and the secondary coil from which the output voltage is obtained, that will be also in the sine form. So, now in the figure, we are finding that there is a laminated core. The purpose of laminated core is to avoid the eddy currents, that is the heat losses. However, heat losses not completely zero, but we can slightly reduce the heat losses. Now, EP is indicating the voltage in the primary input voltage, P is the primary coil, and S is the secondary coil. ES is the voltage output. Now, we are finding that laminated core, these are just in the rectangular form, and the frequency of the output voltage produced by the transformer is same as that of the input voltage. That is, frequency remains unchanged. So, during the transformation of low to high voltage or high to low voltage, frequency never changes. Whatever frequency we feed, the same is the frequency we obtain. Now, in the figure, again, a primary and a secondary coil is indicated. EP stands for the input electromotive force or input voltage, and ES is indicating the output voltage. P stands for a primary coil and S stands for a secondary coil. Between the dotted portion, there are certain lines indicated that primary and secondary coils are insulated from each other. There is a rectangular soft iron core. In a transformer, there are two coils. One is primary, other is secondary. In the primary coil, we pass input, and from secondary coil, we recover the output. And lines of forces are produced when current is passed in the primary. This magnetic field is linked with the secondary, and we find that the output voltage will be recovered. In the step-up transformer, we find that number of turns in secondary will be more, and number of turns in primary will be less. Whereas in the step-down, number of turns in primary will be more, and number of turns in secondary will be less. These lines of forces are indicating that magnetic flux is generated. This magnetic flux is responsible for the generation of induced EMF. Now, this EP is the induced EMF in primary, which is equal to minus NP d phi by dt. This is in accordance with the Lenz's law, and d phi over dt is the rate of change of flux. It is in accordance with the Faraday's law. Then ES is minus NS d phi by dt, and then if we divide the two equations, we get transformation ratio, and K is called the transformation ratio. If K is greater than 1, it will be step up, and if K is less than 1, it will be step down. Transformer core is laminated and is made up of soft iron. Question arises that why it is made up of soft iron. It is made up of soft iron because susceptibility of the soft iron is very small. susceptibility of soft iron is high. Susceptibility is the property of material to gain magnetism easily and also to lose magnetism easily. If we assume that the number of turns in primary coil is Np, what is Np? The number of turns in primary coil, and voltage applied to it is Ep. So the voltage applied to primary coil is Ep and the number of turns in the primary is Np. The number of turns in the secondary coil is Ns and the voltage output is indicated by Es. By varying the number of turns in primary and secondary, we can step up the voltage or step down the voltage. Now, the main formula for the transformation is, that is, Es over Ep must be equal to Ns by Np. Es stands for the voltage coming out of secondary, that is the output voltage, and Ep stands for the input voltage, that is the voltage fed to the primary. Ns stands for the number of turns in secondary and Np stands for the number of turns in primary. So Es over Ep is equal to Ns over Np, that is equal to K, and K is called the constant, the transformation ratio. Thus, the ratio of voltage obtained in the secondary coil to the voltage applied in the primary coil is equal to the ratio of the number of turns of respective coils, that is Ns by Np. This ratio is represented by K and it is called transformation ratio. Now, in order to step up the transformer, step up the voltage, the condition must be Ns must be greater than Np, Es must be greater than Ep, then transformation ratio will be greater than 1. The transformer is called step-up transformer for the given condition. If Ns is less than Np, Es is less than Ep, and K is less than 1, then transformer is called step down. That is, high voltage is converted into low voltage. So the necessary condition for transformer to be stepped down, the Ns must be less than Np, Es must be less than Ep, and K must be less than 1. So what is the transformation ratio of step down transformer? That is K less than 1. And in the step up transformer, the transformation ratio must be K greater than 1. The ideal transformer. However, practically there is nothing known as an ideal transformer. Ideal transformer means that is which is most accurate, but not 100% accurate. Now, input power must be equal to output power. However, we know that output power is never equal to input power. Some losses are there. But for an ideal transformer, we assume the transformation is complete. That is, input power must be equal to output power. Now, input power means the product of voltage and current. So, Ep into Ip must be equal to Es into Is, where Ip is the current in primary coil, Is is the current in the secondary coil. Es is the electromotive force or the voltage obtained from secondary, and Ep is the voltage passed into the primary. So Es is output voltage and Ep is input voltage. So the ratio of Ip and Is is equal to the inverse ratio of Es and Ep. But when we take Ns and Np, Ns and Np are in the direct proportion with Es over Ep. So we find that if the primary current is more, the secondary EMF will be more. If the secondary current is more, the primary EMF will be more. So Ip over Is will, if increase, Es over Ep will decrease. So Is over Ip equal to Ep over Es is equal to 1 over K, where K stands for transformation ratio. If we put the value of K as Ns over Np, we will come to conclusion that it will be the inverse number Np over Ns. Thus, the ratio of currents in the secondary coil and the primary coil is inverse of the ratio of respective voltages. As the voltage changes by the transformer, then the current decreases with the increase of voltage, and similarly the current increases with the decrease of voltage. Due to this reason, the coil in which voltage is lesser, the current will be higher, and similarly, this coil is thicker in comparison to the other coil so that it can bear the heat due to the flow of high current. In step-up transformer, the conditions are Ns greater than Np, K greater than 1, Es greater than Ep, and Is less than Ip. Similarly, in the step-down transformer, the situation will be inverse. That is, Ns will be less than Np, K will be less than 1, K means transformation ratio, and Es will be less than Ep, and Is will be greater than Ip. If Zp and Zs are the impedances of the primary and secondary coils respectively, then Es over Ep will be equal to Ip over Is is equal to Ns over Np. Zs means impedance of the secondary coil and Zp is the impedance of the primary coil. Normally, impedance is the resistance offered to alternating current by LCR circuit. Law of conservation of energy is applicable in the transformer. So, in the transformer, we assume that one form of energy can be converted to energy, another form, but loss of energy is not possible. However, practically some losses are there, but in the ideal cases, we assume there is a complete transformation of one energy into another energy. Efficiency of a transformer is also calculated in percents. So, efficiency is given by function power obtained from secondary coil divided by power applied in the primary coil multiplied by 100. So, this way we calculate the efficiency of transformer in percents. So, it varies from 70% to about 90% because the powers in primary or secondary are not the complete transformation. So, it varies always. Now, energy losses in transformers will be of these forms. Copper losses due to resistance of coil because the resistance of coil cannot be made zero. Eddy current losses in core. So in the core there will be some core in some heat losses are there. Hysteresis losses in core, that is magnetic energy losses. Flux leakage due to poor linking of magnetic flux. So flux leakage means the loss in lines of forces. Now, there are certain uses of transformer, that is step down and step up transformer are used in electrical power distribution. Where we need high voltage, we step up the voltage, and where we need the low voltage, we step down the voltage. So, step down and step up transformers are used in electrical power distribution. Audio frequency transformers are used in radiography, televisions, radio, telephone. Radiography is a phenomenon of taking the photograph of the internal constitution of the system. Radio frequency, which is very high, that is nearly 10 to the power 13 hertz. Radio frequency transformers are used in radio communication. So, radio communication is basically a phenomena in which the audio frequencies are first of all converted into radio frequencies and then they are communicated. So, the process adopted for transforming audio frequency to radio frequency, we take into consideration the concept of modulation. Now, there are certain examples based on the motor, the generator, or the dynamo and the transformer. So, all of these instruments or all these devices are working on the phenomena of electromagnetic induction. They obey the Lenz's law as well as the Faraday's laws. If the number of turns in the primary and secondary coils are given to us as 100 and 500 respectively, then what is the ratio of the voltages? So we are provided with the 5 options. That is, one option is 1:1, other is 1:2, 5:1, and it is 1:5. In order to solve this question, Np over Ns must be equal to Ep over Es, and we find Np over Ns is given to us, that is 100 by 500, so it is 1/5. It means that the number of turns in primary to the number of turns in secondary, that will be equal to the ratio of the voltages, and it will be 1:5. So fourth option will be correct. We can extend this particular fact that Ns according to the equation will be Ns will be 5 times Np, whereas Es will be 5 times Ep. So if we make calculations as shown above, the fourth option will be the correct option.